had a bet that there wouldn't be a single giant model that everyone used for everything, and that there would be many diverse models that are networked with each other, which is how we've seen intelligence grow in humans. The way we think about this is less of a classification problem and more of almost a robotics problem. I I'm a believer in like the law of economics or the Jevons paradox that says the cheaper a utility becomes, the more we spend on it. And so I actually think that even as, the price per intelligence keeps going down, the total amount we're going to spend is only going to go up.
I've met you. We talked about model routing. It was the first time I was not bored with it. So let's talk about it, like sweep away everybody.
Sure, I'll try my best. Yeah, so I think model routing is essentially it's the uh, practice or technique of predictively determining when to use which LLM on each input to maximize accuracy and minimize cost. And I think recently we've all seen like a bunch of headlines around exploding inference spend, and more people are thinking about model routing. But what I think is interesting about it is that it's a deceptively difficult problem. You might treat it in some sort of naive way where you determine, say, whether a request is simple or whether it's complex, and then you send it to one model or another. And actually, what can happen if you take these kinds of naive approaches is you might end up spending more money and actually degrading your performance. Because if you're constantly switching models naively during a long-running coding agent session, you're breaking cache, you're spending more money on those cache misses. And it's also not enough to just look at the single step of, an input and an output, because in long running or long horizon agent settings, each step has an impact on every future step. So it's a really
Maybe
interesting problem. Yeah, go ahead.
I want to double down on that, and I will share from like my experience. I teach a lot of courses on that and I do a lot of lectures. I think I always kind of, I'm not sure what's the nicest word to say, but maybe let's just say a bit bash on
Mm,
model routing. It was something that was in my slide. It
mm,
was like, yeah, this is a pattern of workflow. It was one of the Anthropic's five workflow patterns.
mm,
But every time I was like, yeah, and it works and it's nice, but it's very naive, right? You either do it for a big model and a small model or for a lot of experts.
mm,
And
mm,
when you say that naive approaches don't work as good, I think I'm not really sure why.
mm.
So maybe can you, beyond the fact that like, yeah, of course you have to look at everything, but still, I'm guessing that training a classifier will probably be as good.
So training a classifier can work in a static single turn setting, right? So let's say you have a workflow where you are taking in a document and you need to classify it, right? Or you are handling questions that people have about legal contracts, and it's like a single step. And then you can determine based on that, like, hey, this is a simple legal contract, or this is like a really complex legal contract. And
And you
and
direct it to either haiku or outputs, let's
that's
say.
exactly right. Now, where things break down is if you are, I'll talk about coding agents, which is where most people are spending money today. If you have a coding agent session, which is lasting not one turn, but like dozens or even hundreds of steps with rewards very sparsely throughout that. And not only that, but if you are, let's say very deep in a session and you're working on a very difficult problem, and then a simple request comes up like, hey, can you write a Git commit? Um, but you've built up a KV cache on Opus, which is the KV cache is what allows providers to reuse past messages at a much lower cost. In that case, switching to Haiku might actually end up spending more money because you're breaking and rewriting the entire cache. And conversely, there may be steps where uh, haiku is actually perfectly suited to handle, and you're not incurring a cash loss. But um, the next step or the following steps may sort of have downstream effects of using a simpler model here. So that's why I think the routing paradigm has shifted a lot from the past kind of single turn or few turn settings to what we're increasingly seeing with very, very long horizon
It seems that a lot of it
settings.
is connected to the cache or like the small optimization of long horizon tasks, essentially.
That's right. Yeah. Yeah. So the way we think about this is less of a classification problem and more of almost a robotics problem, where you have an environment and you have an action space of the different models and reasoning effort levels you can choose. And then you have long horizons with sparse rewards. And so we basically train a model to or a policy to determine for each step which model and reasoning effort level to use, which takes into account both the entire past trajectory of turns and model routing decisions, and then also expected future cost and future reward. So this is, I think, a much more apt framework for thinking about the problem of model selection.
Yeah, it sounds
Yeah,
like a very essentially a Markov decision process or like the reinforcement learning kind of framework for model routing. I don't think I ever thought about that,
mm,
and I definitely didn't hear about like something like that. It seems that like from my experience, every time you work with an RL model, it's really complicated. A
mm,
lot of it is even in implementation, it's really, really hard.
mm.
So how you can like how do you handle that? Does it actually solve the case? Does it actually works better for you?
Yeah. So I think, I mean, there's a few nice features of this problem. One is that actions are relatively constrained compared to, say, like a modern robot, right? Where you have maybe hundreds of actuators and other decisions that can be made.
So you said that the
Um,
actions are constraints in the sense that like the actions are which model to choose from, but you
that's
also
right.
mentioned reasoning.
That's right.
So that adds like
So for example, our initial version of the product that we have in closed beta for coding agents works with Anthropic models and their reasoning effort levels. We're onboarding open source models now as well, which gets us roughly twice the amount of savings. But the in practice compared to some other sort of RL or MDP settings, it's not a unmanageable number of actions. And the other nice feature of this is that we're focused primarily on coding agents, which has a fair amount of repeatability across a very high volume of usage. So there's a lot of data available to look at and understand which decisions lead to optimal outcomes. And the third is that with human in the loop agents, we one of the things we look at is the implicit feedback signals from developers so that we get intermediate rewards throughout the session. So for example, if we recommend haiku on a particular step and the developer's kind of next response is like, that's not what I meant, please do it this way, or they might say, okay, good, let's keep going. We can use that to learn whether that recommendation was actually a good or a bad one at that turn, and so that we can actually continue improving the algorithm in real time. We can personalize it for each individual and their preferences, or we can share those learnings, say, across like all the engineers in an organization.
instead of waiting for the long horizon to end.
That's
So
right. That's right. Yeah.
it's actually really smart. I never thought about it like this. I also wanted to essentially ask, like when we talked about in the conference, you've mentioned that the first model that you built was routing between GPT 3.5 and GPT 4,
That's right. Yeah.
which is like in the Gen AI terms, this is like decades, right? Ago.
Yeah.
So I was wondering if you can share maybe what you did there in the beginning and how do you see the field of routing develop from then to now?
Totally. So we back in 2023, we open sourced the world's first model router, routing between GPT 3.5 and 4. And we approached this basically by taking a burp-based model and using it as a classifier for essentially what we started talking about, a complexity classifier between when a request could be adequately handled by 3.5 and when it would need 4. And from there, the sort of next generation of the router that we built is we also did some research on random forest classifiers, which we also open sourced, and then we we looked at uh, essentially breaking this down more like a recommendation system problem, where you have an input, and then we look for each input the responses from a pool of models and the scores or evaluation scores of those responses, and we use that to learn a prediction from novel inputs to rankings for models. So, and then what that allows us to do is we can sort of adjust the Pareto front of those rankings. So if you say want to give up 3% accuracy for 50% cost, we can easily re-rank these for you on the fly. Now, that is still all kind of within this single or few turn paradigm. And as we've shifted to the kind of long horizon agent setting, that's when we started working on this MVP-based approach. But our previous kind of routing approaches are still viable for simpler settings.
It's amazing that you talk about the Pareto frontier because I feel that now it's kind of gaining popularity in the AI world, but we're talking about like 1, 2 years ago that you started working actively on that. So like that, like, did you think about it because you talked with clients, or did you see it that everybody's speaking about it, or you just looked ahead and thought this will be the problem?
Um, Probably a little mix of all of them, but mostly the last. I I'm a believer in like the law of economics or the Jevons paradox that says the cheaper a utility becomes, the more we spend on it. So back when we were founding Not Diamond, we had people sort of saying, well, models keep getting cheaper. Like, is there really a need to worry about cost optimization across models? And uh, I knew that as models became more powerful and cheaper, the total amount we were going to spend on them was going to increase, which is exactly what's happened. And what I think is actually really interesting is that when Opus 4.5 came out, it was about the same unit economics or pricing as Opus 4.1, but it was a little bit better. And that little bit better allowed it to run much longer with much fewer errors. So now you could start doing like Ralph Wiggum's loops and keeping it going all night, overnight. And that's where costs really exploded. And so I actually think that even as, you know, the price per intelligence keeps going down, the total amount we're going to spend is only going to go up. And when I started the company, or actually even before I started the company, I started thinking about this in early 2022. Um,
ChatGPT or
Actually, yeah, pre-Chat GPT, post GPT 3,
Mhm.
which I started getting sort of seeing that everyone was building towards this future in industry and academia, where we'd have a single giant model that everyone uses for everything. This was just after the kind of scaling laws research was first published, and I felt like that was missing a really important gap, which was that I had a bet that there wouldn't be a single giant model that everyone used for everything, and that there would be many diverse models that are networked with each other, which is how we've seen intelligence grow in humans. It's how human brain and communication works. It's also what happened with computing, where we moved from these like giant supercomputers to distributed networks of much smaller and specialized machines. So that was sort of the driving principle, and yeah, so it's I think it has been validating to see the amount that we're, the discussion around Pareto dominance and cost efficiency, but I still think we're very much at the beginning. And I think the next sort of piece of my thesis that I still believe very much in is that we will not only see diversification over cost and performance, but also cross domain, right? And I think models will become increasingly specialized so that you might have a model that is very strong at moderate difficulty code ingestion and reading. And you might have a different model that is good at legal contract writing. And I think in the past, we have sort of dismissed these efforts because of the amount of work that goes into maintaining these kinds of specialized models. But I think RAMP's recent research on sort of adapters that you can transport across frozen models for fine-tuning
Mm.
specialized models, I think is really interesting and points in this direction of increasing intermodal operability.
May I ask if you think routing is the only, or it's the best solution for that, or do you believe other solutions are there? Are you actively researching for those, or?
For like cost optimization.
Yeah.
So I think there's like two other pieces here. One is the models themselves. So
Mhm.
I think there's obviously a lot of research being done into how we can get smaller models that are more intelligent, and I expect that to just continue. Um, but the other layer is the context management. And so right now, I think we're still very early in our principles for context management. And I think that's both on the sort of system side and on the model side. How do models actually effectively deal with context? And and so routing is somewhat orthogonal to this, though we have to look at context when we're making routing decisions, both on capabilities and how they evolve as context window utilization increases, as well as the impact of context window utilization on the KV cache economics. Um, but yeah, I think there's a lot of really important work to be done there, and I haven't been totally sold yet on any of the token compression techniques like RTK or Caveman, for example, for a number of reasons. They focus on
Maybe
model.
just before, what is token compression?
Totally. Token compression is basically a pre-processing step where before context is fed to an LM or informs like its output, it is compressed. So that means it's in some way, shape, or form reduced in the total amount of tokens while hopefully retaining the exact same semantic
Mm.
value. So similar to file compression, right, where you want to maintain the sort of fidelity of the original file just at a smaller size. Token compression is looking at,
Mm.
or context compression is the same problem. And I do think we have good reason to believe from the history of information theory that there is value in this line of work. I don't think anything in the market quite works today, and so I'm very interested in folks' work problem.
Yeah, it's actually, I think it's the first time I'm hearing about token compression, which is make a lot of sense, right? So I'll definitely look more into it. And one last question, not Diamond. Such a long name for a company. Why? What does it mean? I'm
Yeah,
guessing there's a story.
there is a story. It's a reference to modal logic. So in modal logic, the diamond operate. Modal logic is the logic of possibility, and the diamond operator means possible. So not diamond means not possible. And the philosophical backstory is that I think language is our kind of greatest technology that we've ever created, and every major improvement in the technology of language has allowed humans to expand the space of expression, possible expression, into what wasn't possible before. And these kinds of expansions from speech, writing, printing, code, and now AI have sort of driven the greatest changes in civilizational growth in the history of our species. And so the sort of long range motivation for what we're doing is to continue expanding this technology into what is impossible today or in the past. That's the like heady backstory, but it also just sounds cool and
The
has
amazing logo.
yeah, yeah.
Amazing logo.
Thank you.
Thank you so much. It was so interesting. And thank you for having me here.
Yeah,
And
absolutely. Thanks for coming by and really enjoyed our conversation.